Change-on-change regression. In this method, we study how the change in one yield moves with the change in another yield. Instead of using the actual yield values, we only use how much the yields move from one time period to the next. The regression formula is delta y sub t equals alpha plus beta delta x sub t plus delta epsilon sub t. Here, delta y sub t represents the change in the yield we want to hedge, and delta xt represents the change in the yield of the hedging instrument. For example, suppose yesterday the yield of bond A was 4.5%, and today it becomes 4.7%. The change in yield is 0.2%. At the same time, bond B's yield moves from 5.1% to 5.4%, giving a change of 0.3%. The regression studies how the 0.2% change in bond A relates to the 0.3% change in bond B. The second approach is level-on-level regression. Instead of studying changes, this method studies the actual yield levels of the two bonds. The formula is y sub t equals alpha plus beta x sub t plus epsilon sub t. Here, y sub t is the yield of the bond we want to hedge, and xt is the yield of the hedging bond. For example, suppose the yield of bond A today is 4.9%. and the yield of bond B is 5.6%. The regression examines how the level of bond A's yield relates to the level of bond B's yield. If the estimated relationship is something like y sub t equals 0.6 plus 0.7 x sub t plus epsilon sub t, it means that bond A's yield tends to move with bond B's yield based on this relationship. This method focuses more on the long-term relationship between yields rather than short-term changes. Both approaches produce regression coefficients that are unbiased and consistent. However, there is a common problem. The error terms may not be independent over time. Instead, they may be serially correlated, meaning today's error may be related to yesterday's error. Because of this serial correlation, the regression estimates become less efficient. To model this issue, the error term can be written as epsilon sub t equals rho epsilon sub t minus 1 plus v sub t. This means today's error is partly influenced by yesterday's error, plus a new random shock. For example, if yesterday's error was 0.5, the correlation parameter rho is 0.6, and the new random fluctuation v sub t is 0.2. Then epsilon sub t equals 0.6 times 0.5 plus 0.2 equals 0.5. So today's error contains some persistence from the past, along with a new random movement.